One of the most effective ways to reduce your exposure to HexChEC welding fumes is to use local exhaust ventilation. In this module, we'll discuss the basics of ventilation and specifically how local exhaust ventilation, or LEV, pulls the fumes away from your breathing zone. The HexChEC Exposure Assessment Tool was designed to help you decide when to use local exhaust ventilation based on what hot work process you're doing and your workspace. Before we go into more detail on LEV, let's first talk about natural ventilation. Natural ventilation occurs when air enters through open windows or doors. General ventilation uses a fan or HVAC system to move large quantities of air to dilute contaminants. It does not capture the contaminants at their source. More efficient and often cheaper than general ventilation is local exhaust ventilation, or LEV. LEV is used to control contaminants in the workspace at their source. LEV is an important engineering control because it removes contaminants before they reach your breathing zone. General ventilation usually does not reduce airborne contaminant concentrations enough for welders working on stainless steel. Certain welding processes require local exhaust ventilation. And whenever certain hot work processes are done in a confined space, the regulations require that you use local exhaust ventilation or a supplied air respirator. Now, a little more about LEV systems. LEV systems have the following four basic parts. 1. The hood or enclosure to capture the welding fumes at the source. 2. Ductwork, which transports the welding fume from the hood to the fan. 3. An air cleaning device such as filter to remove the contaminant from the air so it's not blown back into the shop or into a space where others may be working. And 4. A fan to pull the air through the hood, ductwork, and air cleaning device. An LEV system doesn't have to be fancy or sophisticated or cost a lot. Many welding shops and shipyards put together their own systems with a basic fan or blower and some ducting. How do you decide which LEV system is best for your shop? In the HexChEC manual, we provide you with a list of companies that sell LEV systems specifically for welding. These companies will be able to give you their equipment specifications and help you decide if their unit is right for your job. There are many characteristics of LEV systems that are important to consider for welding operations. Things you might want to think about when selecting an LEV system include the following. Can the hood or duct get close enough to the source of the welding fume to be effective and still out of your way so you can work? Are you working in a fixed location? Do you need to be able to move the LEV around the shop or around large parts? What kind of ducting should you use? If you're working on large parts or in a situation where the fan has to be located away from the welding operation, you might need flexible rather than rigid ducting. The fan's ability to effectively move fumes away from you is important in selecting the right LEV system. In order to meet your specific requirements, you need to look at the entire system. The fan and ductwork function together to make an effective LEV system. Changing one component without assessing the others may make your LEV system ineffective. Depending on where the air is exhausted, you may need an air cleaner. If you're exhausting HexChEC fumes back into your work area, then you should use a high-efficiency particulate air or HEPA filter. If you have a filter or air cleaner as part of your system, you may want to consider how often it needs to be maintained and how and when to change the filters, disposal requirements, and the cost of replacement filters. If you exhaust the air outside the workspace, then you may not need an air cleaner. Check with your local air pollution control agency. Many welders are concerned that the LEV system will pull away their shielding gas. L&I specifies that an LEV system should capture air at a rate of 100 feet per minute at the source. This is known as the capture velocity. This velocity will draw the fumes away from the source without pulling the protective shielding gas away from the molten metal. Capture velocity is evaluated using a testing instrument that can measure air velocity in feet per minute. Industrial hygienists often use these instruments to evaluate the effectiveness of ventilation systems. The best way to maintain a capture velocity of 100 feet per minute is to position the LEV hood within 1.5 hood or duct diameters from the source. Use duct diameters if you don't have a hood attached to the ducting. Otherwise, use the diameter of the hood if it's a sphere, or the longest side if it's a rectangle. For example, if you have an 8-inch diameter round hood opening, the hood should be positioned 12 inches from the arc. If you're working on a large part, keeping the hood at 1.5 hood diameters from the weld will require that you frequently check the position of the hood and readjust its location. Maintaining a capture velocity of 100 feet per minute at the weld also depends on the amount or volume of air in cubic feet per minute being pulled by the fan. Most commercial LEV systems for welding are designed to move the appropriate amount of air needed to use the 1.5 hood diameter rule of thumb. The important thing to remember is to maintain an air velocity at the arc of about 100 feet per minute. It's also important to reduce cross drafts in your welding area so the LEV doesn't have to overcome the competing air currents. This can be done by using welding screens or curtains. The smoke and fumes from welding are hot, so they will rise. So that you're not working against the natural upward movement of the plume, position the hood slightly above but off to the side of the weld. A 45-degree angle is a good hood orientation for capturing welding fumes. You don't want the LEV hood directly above your head, as this will draw the fumes through your breathing zone. Purchasing the right LEV system for use in your shop doesn't guarantee its long-term effectiveness. As with any piece of equipment, maintenance is necessary to ensure that it will protect you in the future. Here, Mike shows how to change the filters on an AQE 2000.
Have a couple of quick release catches right here. You flip the door open. We've got three Phillips screws. You undo the screws, pull the cartridge out, put the new cartridges in.
Refer to the manufacturer's instructions on how to maintain your system so that it continues to work well for you. Used filters should be disposed of according to local waste disposal regulations. In addition to regular filter changes, make sure that the hood and ductwork are in good condition without holes, burns, or kinks that may reduce the effectiveness of the LEV system. In order to effectively reduce your Chrome 6 exposure, you need to wisely choose, use, and maintain your LEV system.
Have you used your LEV today?